Okay, hello everyone watching on the VOD. I'm AJ, staff engineer at Datadog, and work on serverless stuff. I'm also an AWS hero. Been working on this project, putting BUN in AWS Lambda and kind of benchmarking the cold starts. So that has been ongoing, and what I want to do is a couple of things. First off, Matt Bonig, another hero, asked a question about varying the memory in the BUN example that I have so far. Right now, it is completely configured for just 1 GB of RAM, and I've just had it running like that for like a couple of weeks. And what I want to do is vary that a little bit, see if there's any difference. I don't expect there to be that much of a difference because it's something else I want to talk about today, which is swapping when the CPU and the runtime are sort of fighting, where you don't have enough resources and you are loading more data or allocating more bytes into memory than you have allowed. And then what ends up happening is the operating system will page and swap those memory bytes into disk and then free up more memory in the heap. And when this happens, it really kills your Lambda performance. So something I want to talk about, I think a lot of people run into it for the simple reason of they configure a 128 megabyte Lambda function, which is the default. So, okay, got all this data. Pretty interesting stuff. Sweet. Okay, so the repo I'm looking at today, a Lambda BUN container, I think is the name. I have to fix this because right now it's literally only a Docker container. It doesn't include any instructions on how to do this or how to run this, which is totally useless. So what do we got? Okay, cool. First things first, I don't love that I have to do like a Docker build first. So I wonder if we can improve this. So let's use the built-in. First, I've got to change up the music a little bit. Cool. All right. Don't love that we have to specify an image and get the latest, so let's not do that. Secondly, we should probably figure out cross-compiling, because I realize I'm all on ARM, and I don't know if BUN supports that yet. And finally, what we should do is push all this up so people can pull it and make the README super easy to set up. So first things first, I forget all of this. There's a way to do kind of two things with the serverless framework. The first is what I've got, where I just have a container image and I point my Lambda function towards it. And that makes me responsible for building the image, pushing, tagging the image, and then updating the actual Lambda function configuration. We were doing that because I kept running into some caching issues where I would make changes and not see them in my latest image, so I want to fix that. But that makes it a lot harder to use for other people. So I think what I can do is just this ECR BUN. Yeah. Okay, so yeah, in the provider block images, and it's AJ BUN path, and it's .. And this should be just AJ BUN, right? Yeah, image name AJ BUN. Okay. Is that a reference? No, it's literally the name. Let's see if this just builds. Uh-oh. Sorry, yep. I thought that would be a lot harder. I thought that would take me an hour. It seems to be working. There we go, finally. We need to, AWS, what do we call it? Docker login. It's not Docker login. Well, it is, because I'm running a Docker agent. Does this work now? Ridiculous. How do I have to kill Docker? Is that how this works? I really need to switch. So the other thing I've been meaning to do is try out this. this project. It looks really sweet. It combines like containerd and a couple other open source like components into a CLI tool for, is it just macOS? I thought it was everything. Maybe it is. But I've been having so many troubles with Docker not logging in or logging out correctly. And I have to like kill the process and restart it, so come on. But it looks like the syntax is right, so that's good, right? Where did I put this? Oh, Lambda BUN container. So this worked. That's great. It's just a matter of why I can't log in correctly. Okay, let's try the serverless deploy. Let's see if this builds. Okay, that looked a little better. And then there's sometimes I get an ECR error, but that hasn't happened yet. So we're uploading the image. I want to make sure that's working. So I'm going to hop over to the console. Behind the scenes, the serverless framework is, if you don't have one, creating a Elastic container repository, ECR, for you. So let's pull it up here. Actually, I need that metric. I want to talk about that actually. Okay, let's just open a new tab. Should really start using tab groups. Here we go. Pull through cache, that's fine. Serverless BUN. This looks, yeah, October 8th, that's right now. Okay, so this just got created for this application. That's great. 143 megabytes, interesting. Okay. Let's just make sure this works. And I think this will be like a really painful cold start because I believe that this container image is pulled from ECR into Lambda on the very, very first cold start. Even if you have more subsequent cold starts later, it's cached in some way because, well, we'll see it here. Oh, actually, that's already awake. That was really fast. How is that up already? Is it being invoked? That should not have been that fast. Serverless BUN app dev hello. Okay. Oh, yeah. Okay. So it redeployed to the stack I already had. But we must have the init duration. Yeah, so that's still 140 milliseconds. That's awesome. Okay. So that's great. This is working. We need to we need to figure out the README. So we modified the handler to take any event, log hello from BUN, and then return with the current timestamp, which I needed for that cold start benchmarker project we've been working on. So what we need to do now is, I think, just push it and update the README and see if this works. Oh, I don't, actually, should we deploy the stack and give it a new name? Because I don't know if anyone really wants AJ BUN. Let's just do this. BUN image. Okay. Okay, let that run. So I wonder if this gives me a new repo or uses, no, it's the same project name, new image tag. So it'll still be in the same image repository, I believe. Oh no, I wonder if that's just a reference actually. So, okay, one trick you can use if you have a question about how, like why serverless doesn't redeploy your project is to crack open this little magic directory here. So the .serverless directory is, of course, hidden, but it contains two JSON files, one to create the stack and one to update the stack, and then actually a serverless state, but that's not really important for this. In the update stack, we can take a look at what it actually names the resources, but I suspect that's it, right? I think the AJ BUN was literally just an alias in that template, like a variable. So renaming that variable, of course, didn't trigger the stack to re-update. I think a few folks have joined or maybe left. Welcome. If you have any questions about AWS or getting started, maybe learning how to deploy serverless applications or regular applications on AWS, feel free to just drop them in the chat. I'm happy to help while I'm working through this project. And I'll drop the project link in the chat as well if people want to check it out. Awesome. Okay, that is great. So you can see like AJ BUN isn't in this file at all, and of course, like why would it be? It's compiled out when we build the project. It's only needed inside of the template for me to reference the image, so that's great. I think we just push this. Oh, actually, what did I change in index? Yeah, okay. Just like I said, event type. Yeah, because we were looking at the IP address. Okay. Now we have to add the README documentation. This is the most fun part. Okay. Should we title it? I forget the proper way to cite a paper. Don't they normally tell you at the bottom how to cite this paper? Oh man. I don't want to offend any of my friends or people I admire who helped write this, so I don't get this wrong. I'm not even going to cite them. I'm just going to give the link because I think you have to do in order. And I think it would be Brooker, Danilov, Greenwood, and then Piwanka, but if I get that wrong, that's actually a big deal. What do we call this? On-demand container loading in AWS Lambda. Okay, on what? Okay. What do we see in the log? I really don't want to claim this if it's not. Yeah, 1/3. Okay, so 140 milliseconds. That seems fine. So I'm alluding to this, and we're going to talk about it in a little bit, but keep a really close eye on max memory used and memory sized when you configure your AWS Lambda functions. If those are close, or your memory is equal to the memory used is equal to memory size, that is not a good thing. You're not like using the appropriate amount. You're probably swapping really heavily, and it's slowing down your function. So you basically never want these to equal or get that close. I think I turned off all ads and everything. Okay, good. I don't want any ads on this channel. Cool. Awesome. I don't want to say an iteration. Should we add an image of that? Maybe. Okay. Deployment. I think GitHub supports this now, which is pretty sick. How do I do that? GitHub console. I like this. I thought I saw that GitHub supports this. Oh, alias console, it does, okay. I thought I saw a tweet about this. This music is nice and uplifting. Let's just try it and see what it does. What do we call the directory? Serverless BUN app. Oh, should we change this to be a function URL as well? Probably, right? Because I don't think... Let's just do that, yeah. URL true. All right, let's take a look at our beautiful README. Did it work? All right, that's not bad. What did it do when it copied? Oh, I don't like that at all. Well, I swear I saw this tweet. I wonder if I kept it checking and find it again. Wait, yeah, this was the tweet, right? How did this work? I don't know why I didn't like this. Well, them's the breaks. I can't believe that's 30,000 people looked at this tweet. Okay. Cool. Let's go back to what we're looking at here, and let's redeploy this. So redeploying this will remove the API Gateway v2 or HTTP API, and we'll replace it with a Lambda function URL. They are faster, but the biggest thing is that they're free. They're free forever as part of like the Lambda free tier plan. And I don't want somebody to deploy this into like a project and use it for like a year or two and then end up with a situation where they get a bill and they're not expecting it, even if it would only be a couple of pennies. Okay, sweet. That's so fast. I just don't, like, if I really wanted to try BUN in production, I wouldn't hesitate. It's not like, try it out. I think there's plenty of other reasons. Okay. If I wanted to put test BUN in a production environment in a limited way, I would not hesitate in terms of cold start time, given this test. I think there's lots of other reasons you should hesitate. It's still a new project. It just went 1.0. I don't think too many people are using it all over in production, but at the same time, don't rule this out or rule out something like PHP or just anything you want to run in a container image based on this. That's great. Okay, so function URLs are working. Container support worked well. Is there anything else I wanted to do on this project? Should we add an image? I guess we could add an image. Yeah, why not? We have a good screenshot right here. I gotta figure out my screenshots directory. I think I just copied a PNG into, I forget what the default is on macOS. Taking a screenshot, PNG, okay. And then, Does it have to be in quotes? No. Shouldn't. Let's try that. Okay, that worked. Sweet. Cool. Okay, now I want to deploy a couple of copies of this. How do we want to do that? What's the best way to do this? Is it just to copy the app over and over and over again? Or is it, yeah, it might be. Okay, so we've got this fleet of like dozens, more than, 31 different test functions that I've been testing their initialization times, right? Like how fast do these go round trip request times? And yes, there's a lot of noise. That's normal. It's a very large distributed system, and we're running, in this picture in the last hour, we've done 60 invocations on each, so a fair amount. Doesn't surprise me that one or two of them have a little higher init duration. So I think what we want to do, or round trip duration, not init duration. So I think what we want to do is deploy, first off, let's just test out Matt Bonning's theory and try 512 megabytes of RAM. See what happens. Memory size. I guess they don't really need to be in a separate directory. I could put this all in one directory, couldn't I? Or with the canonical way to do this, actually put, probably the right way to do this is to put the image into the image into a directory inside the project and then leave the serverless app outside of it. I think that's what I've used more often. But let's see what we get here. 512 megabytes of RAM. Oh, and we've been benchmarking BUN as well, like for a long time. So Bun's been cooking. The Bun's been in the oven for quite a while. There it is. Yeah, I think we've done over a week on BUN now. Yeah, and it's like pretty solid. Yeah, it's P99 time, right? And we look at P99 time because that represents, in this case, that's the worst of the worst, because this is like P99 cold starts. So of that group of only cold start invocations, what's the worst of those invocations? And that's what we're collecting data for. So now let's go ahead and deselect all of these. Come on. Wow, that is a slow application. All right, and let's look at the last hour and wait for the data to roll in. Why do we have, oh, because it's, I don't know, a couple minutes away. Okay. Oh, am I not doing this? I think I may be doing this every 5 minutes now. Do we, nope. No, right 1 minute. That's fine, okay. Oh, period 1 minute. Let's just smooth it out. There we go, that's why. This is a banging song. All right, we're testing Matt's question now. Where's Matt? Should we reply to him? Just DM him my own name. Let's find out. Cute logo. I mean, you can't fault him for that. Here are our metrics. Let's should we just do like the last 5 minutes? Because now we should have a couple of runs. A little bit more maybe. Okay. I mean, what 395 was a P99 over the last week, so I don't think that's that far out of bounds. What I want to do though, probably not with BUN, but with just another runtime, is show folks what it looks like when a function starts swapping really really enormously during initialization and explain why that happens. And it happens at a much, it happens more frequently than people expect, because I think everyone anticipates that they can like run their application on their machine and look at how many megabytes of RAM it's taking up on their machine. And for a lot of simple functions, it's very, very few. And they just assume that's what it will be like in Lambda. But you are billed for the time, or for the memory that the runtime is consuming too, right? So like the Node.js runtime, if you look at just baseline 0 megabyte functions like no code, just hello world, it takes like 70 megabytes of RAM just to load. And let's take a look, I'll show you. I've got a bunch of these pulled up so we can very easily look. So this is a 1 gigabyte function. Yeah, and it's using 67 megabytes of RAM just to start the node process, just the node interpreter. And I think that's a big, you know, and then you consider that in a 120 megabyte Lambda function, right? 67 of that is already gone just to start the process. So, you know, that leaves you with 61 megabytes to work with in your function itself, which if you're loading a big heavy dependency, like we looked at that IMDb data project, which is just a giant JSON file that's like 55 megabytes. And yeah, you include that in a Lambda function, and all of a sudden you're going to start swapping or eventually run out of memory. AWS Lambda will kill your Lambda function if it uses too much memory at some point. However, that is not, if it can swap and continue to run up to the timeout, it will still work. It'll still work just fine. And that's where I think a lot of performance hits come from. So when you look at like, when you look at Lambda power tuning, there's a reason they draw the curve the way they do. There's a reason it's so common. Like, you look at an execution time, why did that take 35 seconds at 128 megas of RAM, but simply going to 256, all of a sudden it's only taking like 16 seconds to run? But yeah, you're swapping like enormously. In some cases, swapping enormously. I guess in some cases, it's super CPU intensive. I guess in those cases, they're both CPU intensive. Where's the RAM intensive one? Do they show one? This is a great project. Alex did a really nice job on this. It's been around forever, too. Okay, we should see some data. See if, get Matt his answer. All right, so we deployed this probably 15 minutes ago. So no real change. The way to do this really is to deploy multiple copies of the function to compare them side by side, but I think for Matt, he'll be happy with this. Where'd it go? Oh, hey, Regalius, welcome back. Will AWS start caching supported Lambda runtime code as well? Awesome question. They do, but not nearly as well as they do for Docker or container-based Lambda functions. I have to stop saying Docker. They're going to get so mad. Yeah, there is like a naive caching is my understanding. Julian Wood commented on one of my tweets and sort of mentioned that. Will it get better? I hope so. I would love to see just in general better fragment caching. I think for that to work, the multi-tiered cache, I think, is sort of what they just have as a level set. However, that doesn't work. Like multi-tier for multi-tenant is really hard, and that's what they talk about a lot in this paper, right? Like the convergent encryption is what makes this work, so that you can still like encrypt the whole of everyone's container image, but swap out parts from other people and have a cryptographically identical binary at the end of the day, even though you're sharing individual chunks with different users. And that would be a big thing to do. And I don't know if they can do that, because if you have ever looked at the inside of a zip file or played around like generating your own zips, I don't believe they're deterministic, as in if you create a zip file and then cat the first 256 bytes of that file and then create another zip file with the same kind of collection of data, or even like a couple other files in there, it's not like those first 256 bits are the same. That is I think the challenge, that like what compression is doing is very hard, in my understanding, somewhat naively, to combine that with the need to like deterministically chunk and cache. So I don't know if that would be possible. And they talked about this in the paper, right? They talk about how they had to modify how ext4 converts, how they convert the tarballs from container images into an ext4 file system. The flattening process proceeds by unpacking each layer on ext4 using a modified file system that performs all operations deterministically. So that's the challenge. Is that going to be usable with zips? I mean, I hope so. I would imagine there's got to be some way, but we'll find out, right? And if you, like, I've had a bunch of misadventures with zip files over the years. Here's a blog post about kind of a fun one. Oh, do you want to do one? We can do, Regalius, we can do a really quick comparison. Let's just do one. Oh, before we do, I want to talk about this. This is just like a hilarious bug I ran into when I worked at Serverless Inc., when I was working on the serverless framework. We inadvertently copied two identically named files into the same zip archive, and because of the structure of a zip image index, that's totally fine. Like, that's just totally allowed. And then when you convert it from a zip index to a file system, different implementations of unzip will do different things. So the one on your MacBook will ask you, like the default unzip method will ask you which one you want to keep, and other ones will just slap the last one in the index over the top of the first one. So there you go. There's a fun little story about about zips. I wonder if Matt replied. Oh no, okay. Sweet. Regalias, yeah, let's whip up a quick container image for you. Where should we put it? Oh, I've got a lot. Like, there's so many things in here that I wanted to try. Okay, make dir node container. Isn't our... I think we did this. Yeah. Okay, so we can just... never mind. So let's do this. What do we have in this package.json file? Sure, let's just nuke all this. Do you want me to... Do you care what version we use? I actually don't. Yeah. You know what? Let's start a new project. I don't think I got enough stuff cooking in here. Node container. Start with 0. There we go. So I think it still defaults. Do you the version of Node.js matters? Or the version of, I guess I don't know. You have to clarify that for me. Yeah, the version of Node maybe doesn't matter, but let's just keep it simple. Get this garbage out of here. Give us a function URL. Cool. Okay. If we're better off experimenting with the latest supported runtime. I mean, I think you're probably always better off with their runtimes, and not for a performance reason at all, but literally from the standpoint of, security updates and maintenance. So the way I think of it, like if you're building your own image, you're gonna be the difference between like a container image and a Lambda function based on a managed runtime is that AWS Lambda, the team, owns the binaries and like other dependencies that Node needs. So they own not only the Node binary, but then the V8 runtime that lives there, and then any of the other libc libraries that are needed to run V8. So you don't have to worry about them, and I think that's kind of a pretty strong advantage. They're really good about patching them. They patch them very quickly when there's like a security update or some sort of bug or problem. So I think that's like a pretty huge part of Lambda that we don't want to overlook. Performance-wise, I mean, and part of that is like, so I'm using just the latest provided AL2 for the BUN test anyway, so I think you get a fair amount of that in your in your distribution, but it's totally possible for me to, you know, overwrite some of those files in my own container image, which I'm gonna try not to do. Oh, I missed a follow a bit ago. Ninja Tux, if you're here, thanks for the follow, and anyone else who's here, I appreciate the follows. I don't know if I had notifications off or something. I just saw this pop up. It should be on. I guess we'll see if somebody else joins and hits the follow button. Alert should work, but I didn't see it in the feed. But let's get this answer for Regalius. Pushing this container image takes forever. I got the Alex Debris retweet. Okay, here we go. Great. We can't just copy because I'm splitting this shell. Uh-oh. Internal server error. Why? All right. Into CloudWatch we go. Node. Azure MB node container dev hello. What? Oh my god, I do this every time. I am on a M1 MacBook, and this is complaining because I am trying to run, or I've tagged and uploaded a ARM64 container image with a running in an x86 Lambda function, so of course it's gonna fail. Let's try this again, shall we? Yeah, that gets me every time. That's a dead giveaway. I mean, this one is immediate. If you see an exec format error, that is the, or like fork exec, you know, format error. Fork exec is coming from the Lambda entry point file. You can grab this out of a Docker image. You can go and read this. It's very easily available. But the exec format error is what the underlying Unix system is going to tell you when the bytes are in the wrong order. It's compiled for ARM and not x86. All right, this will work then, and then we can tell you cold start times. We also need to look at round trip times, right, Regalius? Because the comparison that I tweeted about here is entirely based on round trip time. And we're doing that for a good reason. We know that init duration doesn't include the time to get the bytes onto the disk, which means that the init duration for Node.js is going to be lower than the init duration, or like the reported duration for the container image. So I want them to be even. And the reason for that is like we suspect that the Node, the managed runtime for zip-based Lambda functions for each runtime is cached on the worker like ahead of time. So you don't have the same caching behavior. Cool. All right, let's see what we got. Oops, I accidentally minimized chat. Still really bad at the streaming thing. I appreciate you all for bearing with me. That's great. Okay. Let's see what we have. So that's reporting a 514 in iteration, but I think that's like the very first one, right? Which is the bytes going from the container to the cache. After this, I think it'll get better. So let's plug this in to our tester. So to do this, I'm just going to open the benchmarker. And I've just been adding a long list of function names with commas, and that should work. So once that finishes, we will start invoking it on a loop in a cold start. And the way we do that, if you're new to the stream, you haven't seen me work on this project before, it's open source like everything I do here. Be cold. This service is super, super simple. It issues a update function configuration to set a new environment variable. When that happens, Lambda, the service, marks any of your running sandboxes that are currently out there as it marks them for deletion. It says these can't take any more requests. It processes them when you're done and then shut down. And then any new requests will hit a new sandbox with that new environment variable. And that's not dissimilar for how deployments work. Your deployment, it does an update function command, and then if you want to change the RAM configuration, environment variables, if you want to change the architecture, if you want to add a Lambda layer or remove one, that sort of thing, that is a update function configuration command, and that hits their control plane. So it's got a pretty low limit of concurrent requests too, which is why I'm surprised we haven't hit it yet. But I guess we're hitting it for a different function. That's probably fine. Okay, so if this works, we should start to see some more cold starts roll through here in another minute or two. Because this was the first one, right? Oh no, this is the second request. So it's using 66 megabytes of RAM. And what was our BUN was using something similar? 54 megabytes, 10 less. Nothing wrong with that. I mean, hopefully we're past the point where we're counting megabytes. Here we go. We got another cold start. 293. Yo, thanks for the raid, Sapiraco. Welcome, folks, from your stream. How's the stream? Hope it was good. How do I shout out? I think I can do that. I don't know if I have that now. I haven't set that up yet. Thanks for the raid. I appreciate it. I'm really sorry I can't give you the official shout out because, to be honest, I'm really bad at Twitch still. I don't know anything about this. One of these days I'm going to learn how this works and, but I really appreciate the raid. Welcome, welcome. For those of you who are just joining, we are talking about running BUN on AWS Lambda. It's a super cute logo. It's a runtime for JavaScript. If you have a TypeScript application or a regular Node.js application, you can sort of drop it straight in there. Thanks, Regalius. Let's try that. / shoutout, not exclamation mark. Hey, that worked. Thank you. Awesome. I'm learning. I promise you all I will learn how to do this. I'll be better. I gotta write that down somewhere. So we've got this project. It's open source if you want to check it out. It runs BUN inside of Lambda in a container-based custom runtime. And the reason we do that is we read this paper about how AWS spent a lot of time and resources improving the speed at which container-based runtimes can start. It's all good though. I just saw AWS figure I'd come through. Yeah, I really appreciate it. Hope your stream was great. Dang, yeah, that's awesome. So anyway, we know that this is now super fast, or better than it was. And if you used Lambda 2 years ago when they first announced container support, it was pretty rough. So the paper is great. Highly recommend it. I'll plug it in chat. We're taking advantage of it, and we're trying to make our BUN Lambda function start and run as fast as it can. So we're experimenting with a couple of things now. We've got this all running in BUN and on Lambda. It's pretty great. And what I want to see now is if did I just get kicked off? What? Yeah, dropped there for a sec. It says I'm still dropped. I don't understand what's going on. We back now. Good. Okay, sweet. Okay, so we read this paper. We know that they can start container-based images much faster than they used to because they do something that's crazy clever where they chunk up each of your container images for all of us, and they're able to actually share those chunks with other people. So if you and I are both using, say, curl, right? Very common binary. It's kind of installed everywhere to make HTTP requests. Maybe our runtimes both use curl. Maybe you're using like urllib3 in Python, and I'm using HTTP in Node. If they're both using curl as like a system call, that's totally fine, and we can just share the same one basically. So they want to start these as fast as they can. They have this conversion encryption method, which allows us to encrypt the entire container image and then chunk it up, and then also arrange those bytes in such a way that some bytes from your image and some from mine can recombine. And then if our encryption keys work, we are able to like start each of our containers, even though I don't know anything about what your container contains. I think is how that works. I watched the talk and try to learn. But regardless, this is what we care about right here. This is the coup de grace. This is the method of the madness, which is there's an L1 cache on each worker. The L2 cache is inside of the AZ your function is running in, and then the L3 cache is S3, which is where the container images are stored. So if you can kind of get a cold start that hits the L1 cache on the worker, it's like super fast. Sweet. Okay. Let's go back to where we're looking at. So BUN lambda dev hello. We're initializing in roughly 140 milliseconds, and I want to compare that for our node service. So we've had a couple more cold starts now. Let's drop it into the metrics and find out. What do we call this? Service node. Service 0 maybe node. It's 0 node. I want container. Yeah. Okay. I'm gonna find the right one. Have you also tested the BUN custom runtime? Yeah, totally. I've tested them all, and they actually both the layer-based custom runtime and the regular in the zip file custom runtime now made their way into my coworker and friend Max's cold start project. So if you check out Lambda Perf, which I highly recommend you do, you can see it down here at the bottom. So the layer is a little slower. Hey, yeah, thanks again for the raid. Thanks for stopping by. Appreciate it. And yeah, we'll have to catch up again next time. So BUN just in a zip is initializing in about 365 milliseconds. And then when you put it in a layer, in at least this run, it says 634. I think that's a little high, maybe an outlier. We don't see like historic cold start times for this. It's just whatever it was in the last run. So I would like to, you could very easily like rule that out as an outlier. You see, as we go to 256 megabyte of RAM, it was just like a better run. However, both of these processes, either running BUN as a custom runtime out of the layer or delivering it in the layer or delivering it in the zip, end up getting compressed and executed the same way, right? They're fetched and loaded on demand when the function starts. With a container-based custom runtimes, or not even custom runtimes, right? You can use the manage runtime in the container. That runtime has this chance of hitting the L1 cache, right? Like the jackpot. And then you have a really fast initialization. And the benefit of any like multi-tenant, multi-tier cache is the more everyone uses it, the more likely those bytes are in that cache in your region. I'm testing in US East 1. I know that's like their most used region. I know that means I probably have access to like the beefiest caches available, and potentially other people who are using maybe BUN or at least the provided AL2 container, which is what my base image is, which means that my most of my dependencies are probably on the worker ahead of time, which is the whole benefit. That's like the performance increase we get. I'm just gonna turn this down just a tad. So that's what we're using and seeing. Now I want to go back. Did this start a bunch? It did. Okay. Container dev hello. So I should be able to just find this function in my metric. Yeah, you got it. What the fuck joke. Thanks for dropping by. Feel free to drop any questions about Lambda or just serverless, or even just AWS in general. Happy to help. Okay, so in Node 18, it's a lot slower on these initial runs, and this is round trip time. So I switched gears a little bit on everyone, and I want to explain why. In the earlier, when I'm looking at the log streams and we're looking at the data that AWS tells us about the init duration, commonly users will say, this is my cold start time. This is not your cold start time. This time does not include the time it takes to get those bytes into the Lambda sandbox created by Firecracker, which means you're missing some of the variance that can occur with larger functions. And I think specifically in this case that matters because the container images are quite large. That's why even comparatively, right, it's like 400 megabytes or something, and then compressed maybe a little smaller. So you're missing some of that time. So what we've done is we use this tool, this project called the Cold Start Benchmarker. Built this on stream a week or two ago. And what we're doing is we are timing when we start a request and timing when we get the response. So we just get, we kind of look at the clock, start the request, look at finish the request, and then look at the clock again, and we subtract the two and we get our duration. To control for as many variables as possible, I'm using a direct request response invocation. So I'm skipping things like API gateway or API gateway v1 or v2. I'm not even using a Lambda URL, even though I suspect it wouldn't be any different. Instead, what I'm trying to do is just strictly hit the invocation plane for AWS Lambda to get as close to, as close to the real measurement as possible. And we're also deploying this function, which is invoking all of this whole fleet of functions inside of the same region. And we should chat about this if you're not aware. So we've got this is the architecture we've been running for the last couple weeks. We have a cron job that's calling this invoker function every minute. The invoker function goes to the test plane and it just causes each function to cold start and then invoke. So it's a cold start, invoke, cold start, invoke, cold start, invoke, all the way down the list of all of the functions in the test plane. We measure all of those times and we're emitting them as a custom metric into CloudWatch. We were using Datadog, but I work there and I don't want to appear biased to people who are just viewing this stream on their time off. So happy to answer questions about Datadog if you have any. But regardless, we're using CloudWatch for this test. So this is super fun, super cool. I think it's a really easy setup, and again, open source. You can clone it and test it out. And the reason we're deploying it in the same region, oh no, I lost my content. Okay. If you're new to AWS or to like a modern cloud architecture, each region is divided into availability zones. And AWS specifically has really good rules around separating their availability zones. They're physically separate buildings. They're on different flood plains, and they have different power suppliers. So the idea is if, an act of God comes through and, wipes out US East 1A, which is one of these availability zones, the other two are still up, and that's important in any kind of distributed systems consensus, right? You don't want to have a split brain scenario where two different nodes think that they're each the primary node. So you can maintain a quorum in this case, and this is kind of the bedrock of high availability software solutions in the cloud. Lambda, therefore, is a regional service. So you deploy a function to a region, and then any of those availability zones can invoke your function. So of course there's some latency, right? Because we have the invoker function, and then we also have the test plane function, right? So it's like the invoker and the test. If those are both in the same AZ, they're in the same physical building, which means that more than likely that end-to-end response time is going to be quicker than when they're separate. Now, the network between these AZs is incredible. I think it's like 20 or 50 gigabit links, like multiple massive, think like massive pipes, and many of them, with the idea being that it limits this latency as much as possible. And the advantage there is it should limit that amount of like jitter and misrepresentation that can occur if you have like inter-AZ versus intra-AZ invocations. So we're controlling for this all by just looking at data over a period of weeks, like hundreds of thousands of invocations over a period of weeks. That's the idea. And when we look at these metrics, I'm looking at the P99. So, all right, sorry, in this case we're P50. Let's look at P99. There we go. So this is P99 over a period of 15 minutes is like the worst in that period. So this is getting better, which is what I would expect. And what I think what we're going to see here is they should get pretty close, would be my guess, as we have more repeat cache hits on the node service. But I'm surprised it's that slow. But again, node isn't really optimized to start fast, right? It's done that for AWS and Lambda in their managed runtimes, but the container-based one is just going to be a regular old image. All right, my phone was just buzzing, so we're going to help Matt Bonig out. Since you're at it, what happens if you do 10 gigabytes? WTF Joe, cron job equals event bridge scheduler. Yeah, that's totally correct. Yep, I'm using a, they were called CloudWatch events. I forget what they're called now, but I'll show you. I believe it is a event bridge scheduler. Come on, tell me the trigger. That's not a, oh, this is the wrong one. Ooh, I like that you call it BUN time, Regalius. Does BUN time have a lower cold system grid in Node 18? It does. Yeah, sorry, we're looking at that right now. I expect, here it is. I expect this to actually even out. So we're looking at the last 45 minutes of the P99 in that window. So it's continuing to kind of decrease as I think that cache warms up. So we're doing more and more cold starts, so that cache is going to be warmer and warmer. They're using an LRUK algorithm, so the more I use it, the less likely it is to get bumped out of the cache. So I generally am not going to draw a conclusion. Like I've been looking at this for a week before I claim that BUN starts in 395 milliseconds round trip time. A week with, you can see this like hundreds and hundreds and hundreds of invocations. I could probably add them all up too. But now, now we're looking at like the last hour, right? So I expect in another half hour, 45 minutes, we'll probably see a better, a little bit better round trip time. I mean, so this is one of the curses of performance engineering. In any case, there's only so low you can go. You can only cut so much off of it. You have a ton of invocations. How do you blow? How much? I don't spend anything on AWS every month. This isn't that much. It's not that many invocations. You get 1 million a month for free. In terms of gigabyte seconds, which is typically what you go through. So these are very fast invocations. So each of these invocations is only, and it'll tell me, right? Like we can look at the build duration. So my build duration is 150 milliseconds. I forget how many gigabyte seconds I get every month, but it's like, I don't know. I don't think I'm going to get a bill this month either. My biggest bill has been my domain names, which is like they charge you 50 cents a month or something. Yeah, exactly. Okay, exactly. Joke, this is exactly why I love serverless so much, is I can do all of these things and I basically never have to worry about a bill. I'm also really fortunate. I was selected as an AWS hero, and as part of that program, they give you some credits every year that I get to use. I haven't had to use them on my own personal account. I've basically been giving them away to people who inadvertently give themselves a bill and are stuck with it. My very first AWS experience was getting a bill I didn't expect, and that kind of sucked. So I just don't want people to have to deal with that. Oh, thanks for the follow, Joke. I appreciate it. Yeah, and if anyone else hanging around from the last raid, I totally appreciate the follow. Brand new to streaming, if this is the kind of content you like, if you like talking about serverless and building, high-scale applications in the cloud, drop a follow, stick around. Plenty more to come. Definitely appreciate y'all hanging out. Okay, so Matt DM'd me, or not DM'd me, just tweeted at me and said, try 10 gigabytes. Should we tell him that nothing will happen? It won't change anything. Should we quiz chat? Why would, okay. 10 gigabytes versus 512 megabytes. Do we think it will be faster? Yes or no? I guess I kind of gave it away by talking that I don't think it will, but maybe some people think so. I don't know. I guess let me talk through my reasoning. We're looking at something that's sort of myopic, which is how long does a process take to start? So throw concurrency out the window. I don't care about your massively concurrent Go project that has, 1 billion threads and can handle a quadrillion, requests per second, right? That doesn't matter. And throw out your, throw out your event loops in Node, right? Because you're not processing anything. The event loop is totally empty. And what we're doing is we're actually just starting the process, which is going to kind of do two things, right? It's going to read the bytes for that the node process itself and then interpret the file. BUN is a little different because we pre-compile it, but still that intermediate representation, which is true for like .NET or Java as well, that has to be read into memory. And then also as it's reading those the files into memory, that is executing and evaluating code. So the reason you see a very wide difference in cold start times at application time is that sometimes you're loading a dependency that makes a bunch of actual, like evaluates conditions or evaluates logic in your application when it's initialized. So the more that has to happen, then the slower that will be. The second thing, and probably more common, is allocations at load time. Big in Go and Rust especially, where you're gonna have to allocate a bunch of space on the heap. When you do that, you have to hand off to the kernel and say, okay, I need to go and reserve some space on the heap. Can you go and give me back a pointer to memory of this location size? And when you do that, that's a bunch of handoffs between user space and kernel space. And at the same time, like the runtime does a pretty good job of that. But the more allocations your application does at startup, the slower it will start up. So I think if you're a Go programmer, you probably know about Go init debug. It will tell you what, I think it's Go init debug. I think it's go init equals 1. Yo, thank you. Look at hype. That's great. Oh my God, what happened? Oh, Melky, you raided me. I'm so bad at Twitch. Melky, thanks for the raid again, man. Really appreciate it. Welcome everybody from Melky's chat. We're talking about why your Go program is slow to start. I gotta find this environment variable. Wow, welcome everyone. Thanks for dropping by. If you're into AWS or you're into serverless stuff, feel free to drop a follow. That's what we're talking about today. We've been working on BUN. BUN is this really exciting new project, a new runtime for JavaScript, and we're built this container image for Lambda, which we found is like the fastest way to initialize a Lambda function. Thanks everyone for the follow, and look at all these sweet emojis. This is great. Oh, we got some Primogen emojis. I need to figure out the emoji game. I got an email from Twitch that said I can use them now, so that's great. Hey everyone, this is great. What's the startup time for BUN? Great question. The startup time for BUN is around 140 milliseconds, which is pretty good. So we were just looking at one. Let's pull another one out. 135.19 was the last run that we did. What time was this? 22:52:18. So only, yeah, like 3 minutes ago, 2 minutes ago. AWS does not support BUN Amber code, not yet, but you can run it as a custom runtime. If you're interested in running BUN, I got a project for you. I'll drop it in chat. So far, I think this is the fastest way. I think I'm the only one who's done this so far. But I think this is the fastest way to start BUN inside of an AWS Lambda function. Thank you for the follows, everyone. This is always so overwhelming. Can you do some Go Lambdas in AWS? Yeah, absolutely. We can do some Go Lambdas in AWS. They start really quick. The problem is that the Go runtime is the actual the bits of Go that make it so good are kind of heavy. And the way I would describe that is that Go typically doesn't dynamically link against anything. It's a statically linked binary, and it doesn't use like glibc. So as a result, you get like super consistent deployments everywhere you run Go. But it's, I think Hello World in Go is roughly 10 megabytes, which is a lot, right? If you look at like a Rust binary for Hello World, it's like a couple of kilobytes, and that's what gets you in Lambda. Like the thing that gets you in Lambda is reading bytes when it initializes. That's the slowest part. Okay, we have to reply to Matt. So Matt Bonning is also an AWS hero. He asked, what happens if we run BUN at 10 gigabytes? Should we run BUN at 10 gigabytes? Let's put more power in here. Hey, Joke, thanks for dropping that link. Appreciate it, man. Yeah, lots and lots of easy runtime lists. Do you like PHP? I don't even know how to pronounce your name. I think PHP is great. PHP powers so much of the internet, you guys. It's so much of the internet runs on PHP. How can you hate PHP? Do I write it? No, I don't write any PHP. But it's everywhere. I mean, WordPress is like 85% of all websites on the planet. That's pretty awesome. If I were a PHP developer, it would be hard not to just say scoreboard every time somebody complains about that language. It's everywhere. All right, let's go back to BUN and let's give it more juice. Should we give it 10 gigs? So we did 512 megs. Let's do 10 gigabytes. Spend some money. Get that Lambo. That's right. Spend some of those AWS credits. All right. New PHP is pretty good. Yeah, I think it's great. I mean, it's got types. If anyone hasn't seen Aaron Francis's video, let's take a look. I think this video has tens of thousands of views. Oh yeah, I'm also live on YouTube right now if anyone's interested. I stream there because Twitch's like retention isn't that good. And YouTube lets you run it forever. Oh no, that's Prime's video. Yeah, here we go.
Welcome to this overview of Laravel.
Check this out.
I'm going to give you an overview of Laravel, the framework.
Where's the other one? Oh, PHP doesn't suck anymore. This is the one y'all should watch.
Every time I make a video on PHP, which is basically all the videos I make, I get the exact same comment. PHP is dead. PHP sucks all the time.
I really aspired at Aaron Francis's level of humor in video production.
I've worked at PHP since like 2012.
Would I say BUN is production ready? No, I would not say BUN is production ready. I think it's 1.0 and that's awesome. From the standpoint of cold starts, I don't think you have anything to worry about if you wanted to run BUN in Lambda. Like I wouldn't hesitate to run a project in BUN, probably even one in production depending on the use case, given the cold starts we can see, right? It's just not that bad. They're very much on comparison with traditional runtimes, and I think the support's pretty good for a container image, so I wouldn't worry too much about it. What would I worry about? I would worry about I would worry about like panics and crashes and some of the other 1.x stuff you would expect, right? Like Node has a lot of technical debt because it's fixed a lot of problems, and I just don't know, for what I run, like would I migrate a giant project to BUN today? Probably not. Yeah, 1.8 thousand issues, of course. And like that's a sign of a successful project, right? Any successful open source project is going to have thousands of issues for every edge case and nuance. And I think that's totally fine. And I think they're doing a good job. It's not completely compatible with Node yet. And that's kind of part of the problem. Yo, thanks for the follow, Marion Lime. I appreciate it. So I wouldn't say it's production ready as a general term. For Lambda, though, I think BUN is super interesting because it starts fast, as we can see. You can pre-compile your entire project. It's got native TypeScript support, so you don't have to worry about transpiling, which in theory makes things like stack traces a lot easier. And you're basically using, you're not doing a bunch of the node compatibility things that you might be doing in a larger project, right? For the most part, Lambda functions are going to be using the AWS SDK to implement pub sub, implement some sort of delayed job or background job process, or implement, like a basic API server talking to backed by like DynamoDB. And if you're going to do that, I think BUN is probably perfectly suited for that right now. Like I don't think there's probably anything missing. I haven't had any problems. I've been playing around with the AWS SDK and BUN for a bit, so you can definitely check that out. I'm not going to watch this whole thing, but it is hilarious. So shout out Aaron. Love this video. Okay, we've got a 10 gigabyte container image deployed. Oh, another raid. 3 raids this screen. That's crazy. Yo, thanks for the raid. Is it Sabin? I just learned how to do a shout out. I'm super stoked I can do this now. Thanks for the raid. Hope you had a good stream. Feel like a pro now that I know how to use a shout out. Okay. Let's go back. Hey Justice, welcome to the stream. 10 gigs is crazy. 10 gigs is crazy. I've only really seen people who need 10 gigs doing like heavy data processing or ML inference. Hey, everyone go and follow Sabin. Appreciate that. Regalia's 10 gigabytes is the max size for a Lambda function. 10 gigabytes seems too large. I mean, 10 gigabytes is crazy, Justice. It's if you're doing a ton of CPU intensive stuff and you need the like 7 vCPU cores you get. I have a heavy Lambda that uses 6 gigs. Yeah, totally. I think between 1 and 5 gigs is probably very typical. I really would hesitate to go under 1, and actually for the most part, everything I do in the real world, I like basically set at 2 gigabytes. And that's it. And the reason is that you get a second vCPU core. That makes it much easier to run things like, for example, when you are running an AWS request, it uses sigv4 to sign a request. Let's see. So where's my, yeah, huge files is a big one, but like, let's look at a simple example. You know, we have like a Lambda function that maybe talks to, what should we just say, SQS. Where's my queue? Am I zoomed out or is it just small? There's S, here we go, okay. Yeah. So when you're doing this, this request is signed. Why are these so small? No, okay. So this signed request is using sigv4, like AWS's signature version 4, and you can offload a ton of that onto that second core. So that's why I mostly run 2 gigabytes. It's not, but it's what the customer wanted. Yeah, I mean, there's nothing wrong with that. You know, spend a little extra money, get a fully managed experience, and you never have to worry about patching a kernel or updating a server or buying a reserved instance. I mean, it just depends how often it's used. Lambda is really, really good for like the Taylor Swift case, where you just, you know, once a year you've got 1 million people that show up and want to buy tickets, and then it can scale out really, really, really quickly. That's one of the reasons I love it. That's one of the reasons I use it so much. I am a fan. I have my own K8s cluster. Yeah, so I run. I work at a company called Datadog, and all of our, like, the services that my team runs are all backed in K8s. All right, let's see if we got a little bit better result. So we're comparing here Node 18 and BUN, but they're both in a container. And Node is quite a bit slower at P99 at this point over the last 15 minutes. What's P50 though? Okay, P50 is a little better, a lot closer, and average. The reason we look at P99 instead of average is a big part of you know, performance at the margins, and that's why I kind of always look at that. Do you use serverless approaches in Datadog as well? That is a good question. So a lot of our internal teams use Lambda for different things, but Datadog's entire like application customers use is multi-cloud, and that means that we're running kind of everything in K8s. So I don't think anyone's using Knative, although we are experimenting with V8 isolates again for like internal stuff, for like a query nodes. Can I do P99 here? Yeah, I can. So there's like P99.9. Should we see how many 9s it'll let me go out to? Okay, just 2. That's not bad. So 10 gigabytes of RAM. How did that help us? Serverless BUN app. Hello. Serverless BUN app dev. Hello. So I don't think we saw any real change at 10 gigabytes in round trip time. Looking at the last hour, not really. Let's look at a couple of examples. That's the wrong one. Yeah, I'm only running Hello World, exactly. And that's the point, right? It's just... Justice, that's a totally valid burn. I do not have enough data to even care about P99.99. I was just curious if it would let me. No, we're not even close. We've been running this whole fleet of tests, though, for a couple of weeks now, and I think those, you could say, have enough data. If you're just joining, if you've never seen the stream, I am working on a talk for a conference that AWS holds every year in Las Vegas. It's like right after TwitchCon. Hey, Amor. Yeah, big time. No, I just I picked up 3 raids today, so I've got a couple of folks hanging out in podcast mode. If you haven't heard of reInvent, it's a giant conference. Yeah, it's the reInvent thing. Exclamation mark reInvent. You can follow my talk. It'll be on YouTube afterwards, and we can probably even watch it on stream, which would be weird hearing myself speak. But I'm like doing a bunch of myth busting. I'm doing a bunch of serverless myth busting. So what we've done is we've tracked, and we've already extracted some of this data, but we've looked at like the init iteration versus Lambda function size for code you load, code you use, you know, dependencies you grab, maybe AWS SDK or Moby or React or any of these node modules, We did the exact same thing with Python. So we just grabbed a bunch of Python modules for the Python crowd in chat. And we benchmarked how long that took to initialize using all like a 1024 gigabyte, or sorry, 1 gigabyte Lambda function. We're playing around with the container image in BUN. And then we also looked at what happens if I just push bytes into the zip and load them, or and not load them, and the init duration doesn't change from 0 to 250 megabytes. Opinions on X-Ray versus Datadog for Lambda tracing. I mean, I do, obviously. I think Datadog's tracing is a lot better. We allow you to set sample rates. X-Ray just, you're forced into whatever they select. There's a bunch more that we do that they don't. I think one of the coolest things we do that they don't is called cold start tracing. So if you're building Lambda functions on AWS, the number one contributor, like we've demonstrated empirically for your cold start time, is the modules you load. But if you don't want to do what I'm doing, which is spend a lot of time like copying and loading each one, you can just drop in Datadog and you can get a flame graph, and I'll show you what it looks like. They look like these. So you can see a flame graph that shows you exactly how long each of your dependencies take to load. So for example, if you load the whole AWS SDK in Lambda, it takes about 540 milliseconds. We can draw these spans for you, so you can see every single dependency you load and how long it took, as well as the lineage or parenting, which is just a really key thing for Lambda. It helps you identify libraries you can lazy load, maybe libraries you don't need that you didn't realize were loading, and have a bunch of opportunities to just improve the performance of your Lambda functions. Lots of stuff flying by chat. Is there a Rust option for comparison? Yeah, there's Rust in Max's example, and totally. One caution about, and I love Max and I work together at Datadog. We're on the same team. Love Max, by the way. He's awesome. Great project. This is reporting the initialization duration. It's not reporting the round trip time. So we learned and confirmed with AWS. I sent them an email. I was like, you have to tell me honestly. They confirmed that the init duration doesn't include the time it takes to copy your function code from wherever it's being stored, which varies depending on if you're using zips or containers, to copy that code from the store into your Lambda function and then actually start running it. That second part, start running it, that is measured by init duration. It includes a static initialization time of the Lambda, so code that's outside of your handler, allocations, that sort of thing. We need bar graphs. On what do you get billed? You get billed for duration. You don't get billed for init duration today for managed runtimes. In their documentation, they tell you do get billed, but they haven't started doing that yet. But the reason I care about round trip time, which is what we're measuring here, which is why these numbers are a little higher than you're used to, is that round trip time is what customers experience, what I experience as a user. So the init duration doesn't really tell you the whole story. And you can see this because when we ran this test, just on init duration, when we're not loading the bytes, every result was the same, from 0 to 250 megabytes, which can't be possible because the speed of light is real. So now when we look, and this is super busy, so I'm going to pull some of these off, but let's just compare the 0 megabyte unloaded and 250 megabyte unloaded service. So here is unloaded 0 megabytes, round trip time, 343 milliseconds, P99, and unloaded 250, 586. So if you looked at the init duration, these two values would be the same, probably about 170 milliseconds. But if you actually look at the round trip time, it's very different because it takes time to copy those bytes into the sandbox. And that's why we do it. What does P99 mean in this context? P99 is tracking a custom metric for the round trip time for a request to invoke this Lambda function when it's a cold start. And that code is open source. You can take a look. It's right here. This is a JavaScript file. Yep. Max's project is, I think, JavaScript, but every runtime's in there too. So we're recording this custom metric is the difference between the start and finish time in this request. Hey, welcome to the stream. I don't know how to pronounce your name. That's fine. Yes. Oh wow. Thanks everyone in chat. I'm not used to having this many viewers who can help answer questions. Yes, Rust is totally supported, any binary supported. We're running BUN in Lambda, which is supported using the provided Amazon Linux 2 base runtime, and then we sort of build our binary on top. So we can take a look. The Docker file, so we grab BUN as a builder So this is a multi-stage, two-stage Docker build. We grab BUN, we copy our runtime for Lambda and our application, which is called index, into it. We install the dependency we need, and then we actually compile all of BUN and our runtime into one file. And then we actually pre-compile with a target BUN our index, which is great. That improves the performance. And then we actually copy those files into a base image for Lambda, which is set up on provided Amazon Linux 2, which is the exact same thing you would do here for Rust and for Go, because they're deprecating the Go 1.x runtime. So then you can just, you know, where is it? Where am I? I'm lost. Yeah. So then you can just see like my index file is literally just hello world, you know, hello from BUN, and that returns a response. That's what we're doing, and we're doing this just to really compare and see how fast the runtime can start. But we did just spend a bunch more money because we wanted to give us 10 gigabytes. And should we see if it worked? Configuration, general configuration should be 10. Oh yeah, look at that. That's a beefy Lambda function. Okay. Should we take a look at the initialization time? Come on, CloudWatch. Lots of cold starts in here with 10 gigs. No change. So pretty definitive answer here for Matt, our friend. Also, Matt Bonnig, if you haven't talked to BUN, or if you haven't talked to Matt wrote the AWS CDK book. So if you're a CDK fan, that's why. And I want to make sure, do we copy the right thing? It should say 10 gigabytes. Oh yeah, look at that. That is a big Lambda function. So that was unloaded. Now let's find the BUN, serverless BUN app dev hello last hour. No change in round trip latency in that service. All right. Do you recommend AWS for fetch? Never heard of it. Oh, WTF joke. We got to talk about this. This is big. I do really like AWS for fetch because it's doing something that's important. One second, I will talk about AWS for fetch. Let's. So I'm going to bring this back down to 1 gigabyte because that's what everything else is running. Actually, let's just go back to 512. Okay, AWS for fetch. Why would I use it? So I wrote this blog post, and when I was telling you about Datadog's cold start tracing, but I want to kind of call it back. If you check out the AWS SDK V2 or V3, it's got a lot of code you'll never use in it. So AWS for fetch, the 4 in AWS for fetch is calling back to what I talked about earlier, the request signing. It includes SIG v4 to sign a request so that the API will accept it. And the rest of it is just like a super light wrapper around other AWS runtimes or AWS services. So you get, it's way lighter library than the AWS SDK to work with, like way lighter, which I'm using simply to make like an invocation request. But it's not something that, it depends what you're using. If you're heavily using, you know, SNS, SQS, Dynamo, it may just be better to tree shake your dependencies using like ES build. Hey Justice, does the start time change when using BUN with JS or TS? It shouldn't matter because I pre-build it in the Docker container. I can probably test it, but we run BUN build and target BUN, which will use, I believe, BUN's intermediate representation. And I think that's the same with JavaScript or TypeScript. I don't think that changes. So we can try it out. I mean, like, you know, you can, the index file is super easy. You know, there's nothing here, like we said, but I really wouldn't expect that to change. This is awesome. We usually load only some secrets. Figured that is quite slow, 200 milliseconds, but we weren't sure if that was just a service of the library. If you're not sure if it's a service or the library, you should check out Datadog's cold start tracing, because I can tell you that. We do the exact same thing for V3. I'll show you. So you can see exactly, like, one of the slowest parts of the V3 SDK is loading the STS client. So this is loading SNS, but actually the SNS code is very, very light. You can see that it requires a simple token service, which is big. And that 85 milliseconds to load. If you're also fetching secrets, that is a pretty slow process, comparatively speaking. It's a very good service and it's worth it, but it's slower because you're going to have to make a web request. It's got to be signed, and then that decryption process has to happen inside of like KMS if you're using KMS to encrypt the data, or if you're using SSM. I'm going to grab something to drink. I'll be right back, but I'll drop this in the chat if anyone wants to take a look. All right. Oh, I have to catch up on chat. Was JSI made before the serverless era? No, it came after. It was invented for, well, I wouldn't say serverless. It was invented for, I believe, the CDK in order to write, like you can write code in any language, and then it actually resolves to like a call to a Node.js service that then executes that code. Very surprising to me that there is such a huge difference between C++ and Rust. Kind of almost doesn't seem correct. Well, I mean, I think there are a lot of reasons for that, right? Especially depending on how you're compiling your C++ binary. Like, are you dynamically linking it? Are you statically linking it? Rust has the advantage of, you know, none of that baggage because it's a much newer, well, 2013 I think Rust came out. Newer for languages. But I also think that there's probably compiler flags. I mean, we can check, we can look at the project. Function deployer. No, where is it? Oh, wow. That's a lot of JSON blobs. I love it. Using GitHub as your database is the best part. Where did he put all the applications? Here we are. Runtimes. Oh, it's a Docker file. Well, okay. Max, I don't know if we want a debug build. That might be why this is a little slower. Because it's got, like, we didn't strip the symbol table and it is ready to talk to a debugger. So it's got like the debug client or server. I forget how that works. I don't know. You know, I'm probably wrong. I'm probably reading this wrong. I don't know anything about CMake flags. So if you know CMake flags, if you want to update this, oh, it's not even him. Like, yeah, of course, it's a community PR. Twitch pull. I don't know. I don't quite know the age distribution in my chat, but does anyone here remember Twitch Plays Pokemon? That was a really fun time on this website. Twitch opens a PR. Maybe one day. I don't know what to do. I mean, if I remove this, would it build? I don't know. You know, I'd have to test it out. I don't know anything about how Helix. I don't know anything about who opened this PR. But that's something I'll ask Max at work on Monday. It's really nice to be able to work with him. He's awesome. Okay, rolling it out now. Okay, good. Unchanged. Bunch of questions. That's fine. I'll have to get back to Twitter later. Sweet. You work together. Yeah, Max and I are on the same team at Datadog. We worked together for 2 years and change now. He's awesome. There's a reason that our, like, a lot of what we've been able to do in Lambda has gotten so good lately, and he's a big part of that. Or like recently. Okay, we're back down to 512 megs of RAM. When was this cold start? This was just like a minute ago. Okay, so we're still seeing 140. That's great. While we're here, let's do some other myth busting, shall we? So I think my suspicion that those data points don't seem correct may come true. Can you clarify that? I'm wrong all the time, so I have no doubt if I'm wrong here. A couple more folks joined when I grabbed a beverage. So welcome to the stream. I'm AJ. I'm an AWS hero. I work at Datadog. Work on AWS Lambda observability and performance. I mean the debug stuff. Yeah, I think you're probably right. I think there's a number of things you can do. I mean, we have like 3 or 4 different flags we pass to compile like our Go binaries to make them, you know, more performant in Lambda, and that wouldn't surprise me if there's something similar for CMake. I've been working on this reInvent talk. This talk's all about Lambda performance. As a result, we're collecting tons and tons of data. So one question, .NET 7 AOT means ahead of time compilation, which is basically what we're doing for BUN, right? So if you look at the Docker file, it's got a build script. Like Java or like Java.NET has like a just-in-time compiler and then also like an ahead-of-time compiler. Looks similar to Graal VM. I think it conceptually is similar. I'm not a .NET programmer. I didn't know that so many languages can run on the .NET runtime. That's really incredible, though. It's like old VB, C++, C#, you know, tons of different stuff can run on .NET. But if you're gonna, I think game developers know .NET very well. Mostly a Rust dev. Rust is great. I think if you were gonna design a language for AWS Lambda, Rust is basically what you'd get, you know? Why are my metrics not showing up? There we go. Not professionally, still in school. Hey, that's great. Then you have the best requirements for Lambda. I mean, yeah. I want to get this up and talk about it for a second. And I need to see the right ones because I've got very similarly named service. Service 0 MB. Where's my 50 MB? Here we go. So these cliffs that you see are pretty awesome, and I completely changed which dependencies I was using. The AWS SDK is 94 megabytes on disk, but it contains a ton of tests in them that never get loaded, so it's not really a good comparison. I'm surprised .NET 6 performs so much worse than Java. I don't know, I guess I don't really have a take on that since I'm not probably an expert in either of those runtimes. But does he have Graal on here too? I thought he had a couple more. I'm just gonna tune this down just a little bit. There's also Snap Start on here, which I've heard some people. Oh yeah, and Quarkus too. It's a good project. I mean, definitely. You know, we should we should submit a PR and fix the debug build for C++ because that's quite sad. Yeah, 126 milliseconds for Graal, Java 17. I mean, hell, if you're a Java programmer, that seems like a pretty good deal to me. Or Snapstart too, but that's not even that great. But yeah, so like we're seeing way better in iteration times than this, right? We're seeing 140s, which puts us, you know, in the Ruby, the Python, and Node realms pretty handily. Okay, what we're doing, and then service 250. All right, so this is a pretty clear, you know, as we load more bytes, we take a much longer time to start the application. Makes perfect sense, right? So what about unloaded? Where's my unload? It's not there. Is it there? It's not there. CloudWatch is lying to me. Where's unloaded? It's not present. Thank you. And I would put this on a dashboard, except they charge you by dashboards, which I think is ridiculous. Yeah, 30 milliseconds isn't that much worse. And also, okay, so I'm pulling this all up right now because this is like a pretty fair comparison, criticism of the project that Max put together, which is just that it's only looking at the init duration and it's not looking historically. We're talking about a massively deployed distributed system here, folks. So there's a ton of variance day to day in the 50 to 100 millisecond range, and that's normal. That's just part of the gig. So it's no real surprise that you would see a difference over the course of a couple of weeks. Do they charge for filters? No, I don't think they charge for filters, but I think they charge for a saved dashboard to be evaluated. All right, Grafana. Yeah, we could use Grafana. I like Grafana. I mean, like I said, I work at Datadog. I don't, you know, use whatever works best for you folks. Check this out. Okay, this is what I wanted to talk to you. The top row are bytes we load, and the bottom row are bytes we don't load. Yo, thanks for the follow. I appreciate it. Look at the difference. So yes, there is a huge difference between a total nothing burger hello world node function and then jamming 250 megabytes of node modules into it, but not loading them, right? Not importing them, not requiring them. There's like a 300 millisecond difference in terms of, are we P99 or yeah, P99. But look at how much different it is for what the code you load. So once we start loading 50 megabytes, 100 megabytes, 150, 200, and then finally 250 megabytes, we're at 5.43 seconds compared to 250 megabytes we don't load. It does matter. It does matter that you have bytes in the zip file, no matter what. That impacts your cold start time, but that is a fraction of a tiny amount compared to the bytes you do load in your Lambda function. So I wrote a post about this, but I don't think a lot of people realized, like a lot of people don't realize this relationship, that the curve for loading code is like twice as steep or 3 times as steep as the code that is not loaded, but in the zip. Oh, Justice, thanks for the follow. Appreciate it. And this is your advantage, right? You can make a play on this. If you have a Lambda function that is deployed as a zip file, you can make a play and say, all right, maybe I'm going to lazy load some of the dependencies. Maybe I have dependencies in this zip file that I don't use all the time. Maybe I only need them when a certain customer comes along. And you can use this lazy loading process to improve the performance of your cold starts. And here's exactly how to do it. This service loads Dynamo every time. It's an API. However, they have a needy customer named AJ who says you have to publish to an SNS topic every time you do a write for me. And as a result, you know, I have to load this SNS client. If you do that every time, every cold start, it's going to ding you 50 milliseconds every cold start, right? Which again, and we were already arguing in chat about 50 milliseconds, so I think this is like an important distinction. But the option you have here is to lazily load this. So you wrap this require or import, depending on what you're using, ESM or CJS. You wrap this inside of a method called load SNS. And then if you get a request for the person that needs that SNS client, you can load it. There you go. Now you just saved 50 milliseconds on every cold start. And then when AJ's request comes along, it'll just load that dependency, and it loads it once. Once it's loaded, it's statically, you know, loaded one time into the runtime, so not subsequent times. And you then have that dependency loaded, and you can use it and publish to SNS. So check that out as a technique if you've got a function that has a lot of dependencies, but you don't need them on every invocation. Again, this is most common when you're building a when you're going out and building like a mono Lambda API, if you're putting 5, 6, 7, 8 routes in one Lambda function and sort of serving them from the same function, which is pretty typical, especially for people who are moving from a container or from like a EC2 instance. Just as good question. Does the duration change? Yeah, in this case, it does. You get more CPU during initialization than you do in a normal runtime, depending on your configuration. So for this example, I'm running this in a 1 GB memory configuration. So during init, you get a full unthrottled vCPU, but during runtime, you actually only get about 3/4 of a vCPU. And as a result, it's like 50 milliseconds during init to load or 80 milliseconds during runtime. This will matter less once you hit that 1.7 gigabyte. 1769 is the magic number that gives you one uncapped vCPU the whole time. And that is when you would see no difference. Anything above 1.7 gigabytes. You generally see a substantial performance improvement around there anyway. Like I said, I tend to put 2 gigabytes on all of my Lambda functions. Anything that's talking to AWS SDK or other AWS services, especially if I have other processing to do. So here, like, I've got 2 requests. Those both have to be signed, but I can wrap them in like a promise.all, and they go a lot faster than if I was doing them serially. Because I can sign each one in the other vCPU when one's done, then the other one's free, that sort of thing. And yeah, you just let the kernel take care of that for you. Yeah, so this is a key point I just want everyone to sort of internalize. Like, the code you load, if there's one thing you want to take away from the stream, and again, I appreciate all the streamers who rated me, the code you load is the most impactful factor to your Lambda function. Does this matter in binaries a lot as well? Yeah, it totally does, Joystick. And the reason it matters in binaries is typically they're statically compiled, and depending if they're dynamically or statically linked, that can impact you as well. So Go has a really large runtime. It doesn't use glibc unless you use, I think it's a TinyGo. And as a result, you have to load all 10 megabytes of the runtime before any of your code can start, which is, I think roughly we see 100 milliseconds, right? Every 10 megabytes is about 100 milliseconds or so, sometimes more, depending on how much initialization code is in there. So for binaries, keeping it small is probably the most important ththing. That's the advantage of Rust not needing a runtime. I mean, there's a little runtime. Like, it doesn't have a garbage collector, but it's got a reference counter. Oh man, we should build like a custom runtime, like completely custom. That'd be fun. That's just what JavaScript needs, is another runtime. Only when you explicitly use RC. Yeah. Cool. Yeah, so this is the project. This is benchmarking all of these Lambda functions running out in Lambda, kind of just looping over them, making them cold start, measuring the time. We're using round trip time because, again, init duration doesn't tell you the whole story. We've been talking about various sizes of functions. All of these functions, unloaded 250 megabyte versus unloaded 0 megabyte, have the exact same init duration, but the actual round trip time is very different because more bytes take longer to load in that sandbox. I haven't written a ton of Rust. Max is a really big Rust fan, though. He's got a really cool live stream on YouTube where he streams building Rust things. Very similar architecture that we're doing here. I don't think there's much more I want to do to BUN. This is working great. If you want to run BUN, you can check it out. I used a decent amount, but mostly with string cloning. Those heap allocations are what get you. Oh yeah, if you want to work with me, if you're an intern in the, I guess anywhere, because we hire interns all over the world, we are now opening up internships for 2024, so you can check them out on our website. I think we've got 2 slots, maybe 3 slots in my group. That's great. All right, let's see if BUN has had any difference as we've let this bake a little bit. Not bad. Very similar. Oh, yeah. Sorry. I'll get you the link. Boom. There you go. Devin, 2020 intern. He's now, actually, I just had a beer with him yesterday. He's great. He's in Boston. Bunch of cool folks here. Yeah, we're opening that up. I'm a senior, but open to it. I mean, hey, we hire, I don't know if senior in college or senior engineer, but we got roles open for that too. All right, another little bit of myth busting. So in chat, given we've experimented with this already, right? Like a 10 gigabyte function versus a 512 or like gigabyte function. Do we think that the size of the memory your function consumes would impact your cold start time? Yes or no? So if I have, we can provision Lambda functions from 128 megabytes in size all the way up to 10 gigabytes in memory. That scales along with a little bit more CPU. Do we think that would change the cold start time? And if you do think so, I'd love to hear why you think that. And let's say the application is Hello World in this case. And then I'll do a demonstration. But today it's Hello World. So you have some yeses and some nos. I'm happy to inform you all that I can just show you the data. We don't even have to have the debate. Allocating more memory seems to take more time. That's a good point. And that was what I had thought too, right? My theory is this, or my theory was, because I don't think it really works. So you have inside of AWS, we have this giant, let's make that bigger. So you have like all of the Lambda workers, right? This is like Lambda. But inside Lambda are actual servers. And I know serverless has servers, right? So any one server can only hold so many functions, And let's say you need a 10 gigabyte function. That's like a pretty big chunk, right? So wouldn't it take, you would think, like more time to allocate like a 10 gigabyte Lambda function than it would like a 128 megabyte Lambda function? My thought was yes. So I ran a test over the last 2 weeks. And I'll show you the results. So we've got 128. Oops, that's 512. 256. These are all in Node, by the way. 512. 1024. 2048. 4096. I think I just did two more. Yeah, 8 gig and 10 gig. All right, we ready to see the data? No change. Over the last week, they all have virtually the exact same time. Now, I can think of a lot of possible reasons for this. Are they pre-allocating or something? I think the answer is yes. I also don't think, I think that they're using like mmap instead of actually allocating bytes. So your bytes are only written or like allocated when you actually use them, not necessarily when you like land 10 gigs. I think if what I did was create like in each of these allocate array, like a static array to that length of memory for each one in a loop, I think that would be, well, definitely slower, right? But like that using malloc. Yeah, exactly. Like I don't think they're not running malloc when you start your Lambda function. I think they're just allocating space on the worker node, and then as you overwrite it or reference it, it will clear it out and assign it to your worker. I don't actually know how this works in Firecracker. I read the paper and I've looked at the code. Hey Justice, thanks for dropping by. I appreciate the follow too, and everyone who swung by from the raids. I normally have 0 viewers. I really enjoyed today. I appreciate it. So if you want to ask more performance questions or do more like serverless myth busting or ask questions about learning AWS or learning about being a professional software engineer, I'm more than happy to answer any of those. Drop a follow, and I appreciate it. I think what claim you are making needs to be nuanced. I'm not allocating any memory in these functions, right? But I'm allocating a Lambda function that can use that much memory, which maybe that is the nuance that you're looking for. But it either hints at possible performance optimizations that AWS is making behind the scenes. Yeah, I'm not allocating any arrays. I could do that here, right? Like I could definitely allocate a bunch of memory, and yeah, for sure that takes up way more time. That's already pretty well understood, I think. And if not, we can talk about why. But yeah, exactly. Sweet, a fresh AWS newbie, got to learn for the current job. That's how I picked it up. That's awesome. Yeah, exactly. Ninja Tux, like they're bin packing, so they want to make sure that you can't overrun this service, like this instance. You won't outgrow it, but they're not necessarily like clearing out all of the bytes and handing you like a malloc pointer to 10 gigs, right? That's not how Firecracker works under the hood. Yeah, I think most people are in AWS on the job. I definitely did. Yeah, I definitely did. So along the same lines, I had another couple of questions in the last couple of chats. Is this virtual memory? I mean, yeah, it's all virtualized, right? Like that's what Firecracker is. It's micro VM. Also a Rust project. I don't know if you knew this. The thing that underpins Lambda's virtual machine memory is all written in Rust. Unless you touch the memory, will you pay the penalty? That should be the Lambda's tagline. You know what? I wish they only build you when you use those bytes. Isn't that ridiculous? So we've shown that they don't even like pre-allocate them for you or anything, but you're getting a bill for that 10 gigabyte function. It's a pretty cool paper too. I don't know if folks are interested, but maybe in another stream we can read this paper and talk about why container caching is so impressive on Lambda, or container loading is so impressive on Lambda. They solved a really hard problem that containers have to solve. I think that's pretty neat. I don't think the business people will agree. No, I don't think. I mean, I think there's lots and lots and lots of things that AWS engineers could do or would even like to do that they can't greenlight because of the business. That is what it is. It's one of the most profitable clouds for a reason, right? But yeah, if folks are interested, we could read this paper. We could also read the Firecracker paper. Would I consider working for AWS? Probably not. I've worked with a lot of people at AWS, and I know a little bit too much about how the sausage is made, and I think I'm very, very happy at Datadog doing the work I get to do, and sort of being in their space as an AWS hero. I don't know, never say never, but thanks for the follow, Z-Man. Thanks for dropping by. Never say never, but right now I probably wouldn't take a job at AWS, no. Firecracker, great project. All of your Lambda functions. And I think there's a common misconception on Twitter that only zip-based Lambda functions run on Firecracker. That's not true. Both zip and container images run on Lambda Firecracker. Crazy Monkey, thanks for the follow. Appreciate it, man. Okay, so another common myth busting along the same lines was, okay, will allocating more of a timeout, like a longer Lambda function runtime, cause a longer cold start? Any thoughts on this one, folks? A misconception on Twitter, never heard of it. So if Lambda functions can run up to 15 minutes. We know that they're running a giant load balance distributed system. And we also know that each of these workers has a lease with Lambda. So it's got like a time where it will expire, and presumably the worker node either restarts or maybe they take the underlying EC2 instance out of service. Thanks for the follow, Zap. So do we think that a longer runtime, a longer running time, longer timeout duration would cause a longer cold start as the service has to find, a worker with enough space for your function to run? Any thoughts on that? Well, here, I'll start pulling up the data if people want to debate. 5, 10, 30 seconds, 60 seconds, 120 seconds, 300 seconds, 600 seconds. I think just 900 is left. Yeah, Crazy Monkey. I think the answer is you're right. There's really no difference between finding, I guess in this case we had one really long outlier, but there's not a really big difference between allocating a 5-second function versus like a 900-second Lambda function. So I would, allocate your timeout and your memory for what you consume. And if you're wondering how to do this best, Lambda power tuning is, I think, the way to go. It's a great service. There's some challenges here, but it actually updates your function and runs it over and over and over and over and over again at different memory sizes and timeouts. I think just memory. And it will tell you what the fastest execution time is and also the best per dollar your configuration would be. What I see a lot of users do is they set 128 megabyte limit because that's the default. They deploy 128 megabyte Lambda function and then they see that it takes a really long time to start their application and then they just give up and leave. And I'll show you why. Let's go over here. Start a new service. Okay. So I do that sometimes. Here's the problem. If you have, and serverless framework defaults to 1024 mega or like 1 gig to avoid this. But if you have a 128 megabyte Lambda function, and let's slap a function URL on this bad boy. Let's actually maybe not serverless. Let's load the AWS SDK and like IMDb data. I don't even have to install the AWS SDK because it's provided. Oh, actually I do because I'm using V2. So let's do this. I want to load the whole thing to make a point. And we're running this all in 128 megabytes of RAM. Now, we've got more than 128 megabytes of node modules, so they can't all fit. And even that isn't exactly a good comparison. I know the bytes allocated and bytes read are not the same thing. And especially because the AWS SDK includes a bunch of test information that isn't ever used. But let's, not to belabor the point, let's deploy this and take a look at what happens when your function swaps. Ninja Tux asks, what's your take on when to consider to start using serverless? I mean, I would say like for a ton of things that you're doing, if you're not a large and well-established company and you're not building another service that you're going to deploy into like a microservice environment where you're going to have 5,000 concurrent requests or 5,000 or like 10,000 requests per second, it's pretty easy to start with Lambda and yeah, build it in a Docker container and run it with the Lambda web adapter. If you want to run it as a web service, it's great. The reason I really like Lambda is its scaling model allows me to scale out really quickly when I need it. A lot of the work that I do at Datadog, virtually every service that I'm on call for is an asynchronous service. So you're pushing data to us and I'm going to crunch a bunch of numbers, do a bunch of statistics and store it in various, flavors of data stores. And none of that's happening live, right? That's all async. So Lambda excels at that use case because it can, if you have suddenly, 5 million messages get pushed to your queue or written to your Kafka topic or your, Kinesis shard, you can spin up a number of workers in response to that and start working on that information, working on those new records. So it's really quick. Joytek says, or Joy, I don't know how to pronounce your name, sorry. I would start building small and get familiar with serverless. Yeah, exactly. Like start something really small. Oops, I want to scroll up. Okay. So let's see how long this cold start takes. You guessing it's going to error out? It might just fail. It might actually not. Yeah, it might not start in time. Maybe the next one works. Because if init fails, it will actually run it during... it'll actually run it during the invocation instead of initialization. Swapper. Okay, we timed out. We timed out because we're swapping super hard. Let's just give this here. We'll give it more time. I see this probably more commonly on binary applications like large Go projects or Rust projects even. But just like we're talking about here, you see this like really long tail at 128. It's just not enough memory to load your... Oh, hey, Rect404, thanks for the follow. Is the API gateway default timeout 6 seconds? The default Lambda function timeout for serverless framework projects is 6 seconds. API gateway's default timeout is 29 or 30. I'm actually using a function URL, so this can time out in 15 minutes if I want it to. Which you shouldn't do. Don't do that to your users. Unless you're using like response streaming and you want to send a bunch of data back. Oh, hey, welcome back, QQ. Thanks for stopping back by. This function is just timing out over and over and over again as it's trying to load more bytes than it has memory for. So we can't load this in time. And the reason I want to call this out is a lot of people won't realize that this is to do with running out of memory. Here's the big one. Memory. So this actually did kill my runtime, but it doesn't always do this. It doesn't always kill your function. It will if you try to then allocate so many bytes that it can't swap them out for you, and then you're just stuck, right? If you need to hold on to a reference that's just larger than the size, it will fail. But I see this a lot. I see memory size 128, max memory use 128, and it won't necessarily kill it. And when that happens, yeah, you get into trouble. So let's maybe we can show another example. The only time I would say it's okay to swap super heavily like this, well, actually, I wouldn't really say that, because if you're trying to get price per performance, it's usually more expensive, right? It's like tripling or quadrupling your duration. So you're getting paid, you're paying for all of that time, either during the init duration or just an execution time, depending on where this happens to you. But especially with like loading much heavy dependencies in a 128 megabyte Lambda function, you may as well increase it and see much faster duration, and you're going to get better cost per performance. The downside with Lambda power tuning is that it doesn't run all the time. So you run it once and that's great, but now you have to run it, over and over and over again every time you make a bunch of changes. All right, so we removed the AWS SDK. We're only loading 55 megabytes of dependencies from IMDb data, and it's still gonna fail. And I think it got killed again. Yeah, runtime exit error. So that still took 12 seconds until it killed, and since it didn't initialize, we got billed for that time. Can you not make that part of your testing pipeline? Can you clarify that? I'm not sure what your point is. Oh, and the big reason I'm calling this out is I think a lot of people look at like the memory they're used to using, not realizing that like the runtime also counts. So if you look, like, take a quick run through your code and you're like, oh, I only allocate, I only allocate a few, 50 megabytes onto the heap. Like in your Rust project or your Go project, it won't matter. He wants to build the tuning part in the pipeline. You totally could, yeah. So you totally could. I don't know if you'd want to, because to be honest, like somewhere between 1 and 2 gigabytes is the sweet spot for so many things. So that's just been my approach. Maybe I would do this one day if I really, really cared about this. And again, I definitely do. Is I'm spending hours on stream doing this. But man, I just, I 1.7, 2 gigabytes is just so close to the sweet spot. Will Java containers work faster compared to the supported runtime? I think Java especially is more likely to be your code than the runtime. And that's a big part of like runtime reflection and dependency injection that's super popular in that language, similar to .NET. So I wouldn't necessarily expect that to be that much better in the way we're seeing BUN, because BUN's runtime is only like 90 meg. And I just think that so we got a response. So BUN's runtime is just so much smaller than I think Java's like just-in-time compiler would be. So I'm not sure if that would matter. My understanding is like Java's price per performance curve is way out, shifted way out. Node and Python is like very similar to what you see here, where like we just went to 512, or did we do 256? I forgot already. 256. And that was way, way, way faster, right? So we went from timing out and being charged for 12 seconds of compute time to doubling our memory, and then it's only running for 17 milliseconds. So this is why. And here we're already close to swapping too, right? We're already close to swapping. That at a 1 point. All right, this is what I wanted to get to. I'm really excited we hit this point. So we are using 256 megabytes of Lambda of memory. We are limited to 256 megabytes at this point. Just like on your laptop, if you're familiar with like older machines that had much less RAM, you'd use like a RAM disk. I think that actually still is done. And the reason is that you like some of the memory you allocate can be written to disk and then re-freed in RAM by the operating system, and then your runtime can continue running. So we saw that yes, 256 is great, but look at this massive init duration. Yeah, it's page files, right? And then we can increase this and watch how much faster it executes. I missed your point about dependency injection. Can you come again? I think Java and .NET are just more likely to use dependency injection, which rely on reflection at runtime, which is going to just kind of wreck your cold start time. That's base OS 101. Yeah, I mean, like I said, I think there's some differentiation between like a RAM disk and page file, but the concept is the same, and it still happens in Lambda. Do you always use power tuning to check your Lambda? No, I'm literally, you can do this just with your logs. You can use this with any telemetry provider, like Datadog does this, but so does CloudWatch. I really just compare basically this should set off alarm bells in your head. If you see memory size and max memory used that are equal or close, you're probably under provisioned and either swapping or near erroring out. And in this case, we went from erroring out at 128 megabyte to heavily swapping at 256 megabyte. To now, hopefully we have some breathing room. So that was like 1,300 milliseconds of cold start time. It still might be bad because it's still a lot of bytes to load, but the build duration is so much shorter. So yeah, it's like in the same ballpark, a little bit off, but that we actually need 386 megabytes to run this application. And as a result, right, we're like loading as we allocate through 256, it will page out and that's when you're swapping. So stop the swap. That's the motto. Makes sense. Glad that makes sense. I was just hand stuff. Yeah, so like I don't mind that at all. We set up this whole test framework, which is using these like round trip times, because again, Lambda initialization duration that we're comparing here does not include the time to get those bytes into the sandbox. So we sort of have to like infer them and measure them elsewhere. So that's what we're doing. All right. Going to be kind of wrapping up here as I'm finishing my bubbly water. Are there any other questions or comments people wanted to ask? Otherwise, if you're new to the stream and you drop by and ask some questions, feel free to drop a follow. I'm always happy to answer these questions, help teach you about AWS or talk through some problems. The last stream we did, we talked through like first time setting up an AWS account. If anyone hasn't done that, we can probably do that again. That's pretty fun. I talked about why I'm using a limited permission role. Everything I'm showing you here is a limited permission role so like I don't even have access to billing. What was the Lambda power tuning. Yeah, this is great. Lambda power tuning. Definitely check out Lambda power tuning. This will, it's a state machine running in step functions that will just deploy your Lambda function at each of the stop points. These only went up to 3 gigabytes, but you know, if it'll go to 10 now. Yeah, give it a follow. Give it a follow. Give me a follow if you're stopping by and you like the stream. And yeah, maybe next time we can talk about why I use, I don't even have access to my billing dashboard, why I give myself limited permission. Crazy Monkey, what is the minimum latency of a Lambda function at which economics of scale make it a viable option instead of a method invocation? I'm not sure I parsed your question properly. Where would Lambda, in terms of like invoking something inside of another application? Regalius, I should write a blog about securing AWS account. I totally should. I've been kind of dabbling with doing that for YouTube as I've been having more fun with this like kind of stream and interaction. My thought was I could walk through it all and like record it and clip it onto YouTube. I think every beginning content creator, like I definitely am, tries that and then realizes like creating a YouTube video is much harder in terms of editing and saying what you want to say and having a script and production. Oh, it's orders of magnitude, Crazy Monkey. I don't think it would ever be like Lambda function is always going to be an HTTP call. Even a direct invoke, like with the AWS SDK, like I'm doing, is results in an HTTP2, request. Versus like something like on a local service being a method call. I mean, the reason you use Lambda is to scale out. Record the video live on stream. That's so hard. I mean, I'm recording live right now to YouTube, so you can watch us back later, and the VOD is on Twitch too. But it only stays for like a couple of weeks. Crazy Monkey, I'm not sure how I would answer that question, but maybe if you DM me the question, I can like come up with a better answer, because I'm still not sure like what you're comparing it to. But it's definitely a good question and probably worth exploring for sure. Cool. I'm going to probably wrap it up here. I really appreciate everybody hanging out today. I had a lot of fun. Thanks for dropping by. Like I said, if you want to hang out again, drop a follow. We can do this probably again tomorrow, and love to just, talk more about serverless performance and building on AWS. Deployed a bunch of stuff on top of, Fargate and EC2 and other applications as well, so we can use more of the cloud. I'm going to start rating the Alt F4 stream. If you want to hop over there and say hello. And then, yeah, we'll jump into more of these. Hey, yeah, I'm glad you saw the tweet in time. I try to stream for a couple hours on the weekends. So, all right, folks. Thanks again. Had a great time. Take care.